Well, there it is, the first fully autonomous tractor from a major brand to be ready for commercial market release, John Deere's 8R, designed to work unsupervised in tillage operations and coming soon to a Deere dealer near you.
Until recently, agriculture has always been about doing more with more. More horsepower, more inputs, more acres, but the new digital era is changing all of that. The last decade has been about doing more with less and providing farmers with additional tools to make more informed decisions. Artificial intelligence and machine learning are key technologies to building a continually smart, ever-evolving, and more efficient farm. And that's why they're key to Deere's vision for the future.
Well, that was John Deere's Chief Technology Officer, Jamie Hindman, talking at a January press conference where John Deere announced the pending introduction of that fully autonomous 8R tractor designed to work all by itself in tillage applications. Back in late summer, John Deere announced it had purchased a small California tech startup company called Bear Flag Robotics. Bear Flag had developed a system to turn a production tractor into a fully autonomous machine designed to work in tillage applications. And it was selling that system to farmers in the area of California around where it was based. When John Deere announced the purchase, a senior executive of the brand said the company intended to make that technology widely available through its John Deere dealers in the not too distant future. Now, just a few months later, it looks like John Deere is following through on that promise with the pending introduction of this 8R, which will be available through Deere dealers later this year. Here's John Deere's Willie Pell to talk about exactly how the system on this 8R tractor works.
Hi, I'm Willie Pell. I focus on our autonomous systems. So fundamentally, robots need to be able to do two things. They need to be able to perceive their environment and make good decisions about what they perceive. This tractor has 6 pairs of stereo cameras, which enable 360-degree obstacle detection. And stereo cameras work just like the human eye. You have 2 eyes, but only 1 image. And the brain finds common objects between those 2 images and calculates the distance of the objects. We do the exact same thing with stereo cameras and machine learning. Then machine learning algorithms running on GPUs interpret the output. So the tractor also always knows where it is and where it has authorization to be. It does this by continuously tracking its global position relative to a geofence. And lastly, the tractor has redundant safety systems to make sure core components are working properly. Now, what you're seeing here is exactly what the machine sees. The first column is the raw image. The second is the depth map. And the third is the per pixel classification, in which you can see is that the machine is correctly predicting that the green is ground, the red is trees, and the blue is sky. And you can see this yellow foreign object, and the machine has correctly identified that as well. The fourth column shows the confidence of the classification of each pixel. The more confident it is, the more cyan it is. So putting this all together, you can see that pixel by pixel, this machine is almost perfectly interpreting its surroundings. Now, the RGBD, so that's red, green, blue, and depth. That image the camera is captured, gets passed into the deep neural networks that is trained on hundreds of thousands of images. The neural network classifies each pixel in about 100 milliseconds on NVIDIA GPU processors. Now, depending on whether the obstacle, like a tree branch or an animal, is detected, the machine either continues or it stops. Achieving high degrees of safety and productivity has been the core challenge of this project. And while a farm has fewer variables than an open road, building a production-worthy vision system requires a world-class machine learning research team and many hard-fought innovations. This autonomous tractor is always improving through finding relevant data and training new models with it. In addition to the more than 50 million images we've collected from farms all over the US in the last 3 years, we're constantly feeding it new information and new images. And the training process rewards it for making correct decisions and penalizes it for making incorrect decisions. But one of the things that makes autonomy in agriculture really challenging is rare or difficult to foresee events for which we have no training data. For example, a billboard falls in a field. The tractor needs to be able to stop. However, for an event that obscure, we're not going to have adequate training data. So to handle these types of situations, we've built an anomaly detection system that recognizes nominal scenes of sky, ground, and trees. And when it encounters new objects that don't fit within the standard class of object, the machine just stops. Using this technology, we're able to achieve a very high degree of safety and performance despite situations where the autonomous tractor sees a completely new or random object. And while the sparsity of relevant data is a disadvantage in agricultural autonomy, the ability for the tractor to stop is a huge advantage. When we encounter an anomalous object, we stop. We don't have to worry about getting rear-ended by another driver. And the result is a 40,000-pound machine that is going to be running safely and fully autonomously in farmers' fields this year.